Okay, so we're going to take a look at the study guide for the Mastery Assessment for Unit 5. So if you look at number 1, Ms. Cook is making a tablecloth to exactly cover the tabletop. What is the area of the tabletop? So all I really have to do is count these squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I have 20 squares. But I can't forget, hey, I've got some triangles here. I have 1, 2, 3, 4, 5, 6, 7, 8. And remember, a triangle is half of a square. So if I have 8 of those, I technically have 4 squares. So I'm going to add all those up, and I'm going to get 24 square feet for the area. All right, let's take a look at number 2. Naya's drawing is made up of 1 inch by 1 inch squares and 2 congruent triangles. So there's several ways I could do this. I could count down here because the entire figure is her drawing. So I could say, oh, 1, 2, 3, 4, 5, 6, 7. This is a 7. This is 4. This is 4. So this is 8. So this is a 7 by 8 figure. Or I could say, okay, the base of this triangle is 4. The height is 7. So that's 28. Half of 28 is 14. So these two are 14. Together, that's 28. I could duplicate that over here, 28 plus 28. I'm still going to get 56. So 56 square inches. Okay. Now over here, Connor wants to cover one of the walls in his bedroom with fabric. Which does he need to know to make sure he gets enough fabric? He's not putting it around the border, so I don't need the perimeter. I don't really care about the weight of it. I'm not trying to figure out the capacity of the room. How much fabric will it hold? I'm trying to figure out about that one wall. So I want to know the area of the wall. Okay, number 4, a swimming pool is built with a deck around it. So here's the deck. This shaded area here makes up the deck. So how do I find the area? Well, let's find the area of the big rectangle, which is 18 by 40. That's 720 square feet. And then I'm going to subtract the swimming pool. 10 times 32, 320. So when I do my subtraction here, 720 minus 320, it's going to give me 400 square feet. Okay, let's move on. Number 5, Allison's going camping and needs to get a tarp to cover her tent. She has the following diagram. Now, of course, we know tarps we're not going to stick all the way over the tent. Usually that's what goes on the ground, but they're wanting us to find surface area. So I have 3 congruent rectangles. So they are 8 because, see, that's 8 feet. This is 8 feet, 8 feet, 8 feet because opposite sides of rectangles are congruent. So this is 5, 5, same thing over here, 5, 5, 5, 5. So all of these rectangles are 8 by 5s, which is 40. And then I've got 2 congruent triangles. Well, half base times height gives me the area of a triangle. The height is 4, the base is 5, half of 20 is 10. So when I add these up, I've got 40 plus 40 plus 40 plus 10 plus 10. So 120 plus 20, I get 140 square feet. Okay, now let's look at the next figure. So we're going to use this figure for question 6 and 7. So what 3-dimensional figure corresponds to the net? Well, if I fold it, I'm not going to get a pyramid because it's not going to be a point. So I'm not going to get a pyramid. I'm not going to get a prism that's rectangular because I have triangles included. So this is going to fold up to be a triangular prism. Okay, what is the surface area of this 3D figure? Well, this rectangle is a 3 by 4, so that's a 12. I need to know this side length. I'm going to get a different color. That's 3 because remember, opposite sides of rectangles are congruent. So the center is actually a square, and it's a 3 by 3, which makes this 9. Over here, I have a 5 by 3, makes this 15. Now, these triangles are congruent. The base is 3, the height is 4, half of 12 is 6. Same thing over here. 4 times the base is 6. I'm not going to use this 5. That was kind of there to distract you. That's actually the hypotenuse of that triangle. So the surface area, when I add 12, 6, 9, 6, and 15, I am going to get a surface area of 48 centimeters squared. All right, now we've got a net for a cube. Well, all sides of a cube are congruent. It has 6 congruent faces. 6 times 6 is 36. So each one of these is 36. 36 times 6, or I could just keep doing 36 plus 36 and so on, is going to be 216 centimeters squared. Okay, number 9, the length of a rectangular foam packing block is 9 inches, the width is 3 1/4, and the height is 2/3 of an inch. What is the volume? I'm just going to multiply all these together. Length times width times height. So 9 over 1, 3 1/4 becomes 13 over 4 because 3 times 4 is 12 plus 1 is 13. And then I've got times 2/3. So 9 times 13 times 2 is 234. 234 divided by 12 is 19.5 or 19.5 inches cubed. Now, number 10, you might think, oh, this is dealing with volume. I got this. 8 times 5 times 12. Nope. It tells you that there's going to be miniature dice that are 1/2 by 1/2 by 1/2 inch. How many dice can fit in the box? So it takes 2 halves to equal a whole. Well, I have 8 holes down here. So 8 times 2 is 16 can fit over here. And then 10 and then 24. So 16 times 10 times 24, I can actually fit 3,840 dice in that box. Okay, number 11, this is a 300-page book. It's 10 inches long, 8 inches wide, and 3/4 inches tall. I can find the volume of that by doing 3/4. You know what? I'm going to make that 0.75, a decimal. 0.75 times 10 times 8. Remember, order doesn't matter with multiplication because of that commutative property. So 0.75 times 10 times 8 is 60. But you know what? That's the volume for a 300-page book. I want to know the volume for a 100-page book. So once again, make sure you're reading these questions in their entirety. So 60 divided by 3 because it takes 3 100s to equal 300. So 60 divided by 3, 20. So the volume of a 100-page book is 20 inches cubed. The volume of a 300-page book is 60 inches cubed.